Hi everyone, today we're going to take a look at the lesson for week 2. And this is like the week 2 standard lesson packet. This packet is a review over everything that we've been learning throughout the entire unit. The first section is to solve each systems by graphing. Now I don't have the packet printed out and I don't have graph paper, but I am going to be able to show you how to do the math and then walk you through a rough sketch of the graph. Number 1, you have 2 linear equations. The first one is y equals 5 halves x minus 1. And the second linear equation is y equals 1 half x plus 3. Linear equations mean this is y equals mx plus b, y equals mx plus b. The first thing we want to do for both equations is identify what is the value for b and what is the value for m. To do that, we just look at our equation. Our m is lined up with this 5 halves in equation 1. And the second equation, our m is lined up with the value of 1 half. So this makes my m 5 halves and 1 half. Then we can identify what is the b value for both of these. -1 and positive 3. When we look at our values for m, we remember that m is our slope and it is our rise over run, or the change of the y-axis, the change in the x-axis. So a rough sketch of what this would look like on a coordinate grid. For our first line, equation number 1, b is our y-intercept. It is also our beginning point. So on my y-axis, I'm going to plot a point at -1. So here's 0, -1. I would plot that point. From my beginning point, my y-intercept, I use my m, which is my slope, to move across the graph. And we remember that it is rise over run. I'm going to go up 5, 1, 2, 3, 4, 5, and then I'm going to run positive 2. I'll connect those dots and draw the line. For my next equation, I'm going to do the same thing. I'm going to start with my beginning point, my y-intercept, my b, which is at positive 3. So on my y-axis, I'm going to find positive 3, 1, 2, 3, and plot a point. From there, I use my m, my slope, to move across the graph. I use my rise over run. I'm going to go up 1 over 2. And I'm going to sketch that graph. My final step is to find the point of intersection. So every time we're doing these, we are trying to find the x and y value where these 2 points intersect. And we can see that on this graph, they cross right here. And that point is at, my x value is positive 2. And my y value would be positive 1, 2, 3, positive 4. So you can see that the solution to number 1 in our week 2 packet is 2, 4. Moving forward to number 9, which is the new section. Number 9 asks you to solve each system by substitution, specifically where we are setting y equal to y. On number 9, you can see that your two equations are y equals 2x plus 6 and y equals negative 4x minus 12. If I know for a fact that y equals 2x plus 6, and I know that y equals negative 4x minus 12, I can set y equal to y because that is a true statement. Then I go ahead and plug in the numbers. What I really have is 2x plus 6 is equal to negative 4x minus 12. At this point, I'm going to draw a line down the center so I can keep track of my left side of my equation versus the right side of my equation. My first step is to move all of the x terms to one side. I'm going to work first by moving this negative 4x. We cancel out a negative 4x by adding 4x to both sides. Negative 4x plus 4x is 0, so that's going to cancel out. But if I added 4x to this side of the equation, I also need to add 4x to this side of the equation. So I'm also going to write plus 4x. 2x plus 4x is 6x. I'm going to bring down the positive 6 from my equation. I'm going to keep my equal sign. And I still need to bring down this negative 12. Make sure that you do not lose that negative sign. Negative 12. Now that all my variables are over to the left side of my equation, I need to push the numbers over. So if I look at the side of the equation that x is on, I need to move this positive 6. Well, we cancel out a positive 6 by subtracting 6 from both sides. 6 minus 6 is 0, so that cancels out. All I'm left with is the 6x that I need to bring down. Now I need to figure out what is negative 12 minus 6. You can use a calculator, you can use a number line. Negative 12 minus 6 is negative 18. I still need to get x by itself. This now says 6 times x. I'm going to cancel that out by dividing 6 from both sides. 6 divided by 6 is 1. So I'm left with 1x, which is what I've been looking for. Negative 18 divided by positive 6 is going to give me negative 3. So I now know that my x value is negative 3. I still need to plug all of this in to figure out what is y. So I'm going to take this x equals negative 3 and I'm going to plug it back in anytime I see x in another equation. I'm going to work with the top one where it was originally y equals 2x plus 6. But now, every time I see x, I'm going to plug in what x equals, which is negative 3. So I have y equals 2 times negative 3 plus 6. 2 times negative 3 is going to give me a negative 6. I'm going to bring down the rest of my equation. Negative 6 plus 6 is 0. So I now have that y equals 0. The point of intersection and the answer to number 9 on your week 2 packet, we write as a coordinate x, comma, y. Our final answer is going to be negative 3, 0. The third and final section on your packet is to solve each by substitution. And this is where you're actually going to plug in a whole expression and then use the distributive property to finish solving. Together we're going to take a look at number 17. Number 17 says negative 2x plus 2y equals negative 6. And it also says that y equals 4x minus 9. If I know that y equals 4x minus 9, then in this top equation, every time I see the value y, I can plug in this expression 4x minus 9. So my first step is to rewrite this whole expression using 4x minus 9. I'm going to keep my negative 2x plus 2. But now instead of y, I'm going to plug in what y equals, which is 4x minus 9. And all of this still equals negative 6. My next step is to use the distributive method. I have to take this positive 2 and multiply it to everything inside the parentheses. For now, this negative 2x is going to be written below, negative 2x. Positive 2 times positive 4x is positive 8x. Positive 2 times negative 9 is negative 18, and all of this still equals negative 6. My next step is to combine my like terms. I have this negative 2x and this positive 8x. When I combine those like terms, negative 2x plus 8x is going to give me a positive 6x. Now I need to bring down everything else. So minus 18 equals negative 6. Now I just need to get x by itself. I need to move this negative 18. I move this negative 18 by adding 18 to both sides. Negative 18 plus 18 is 0, which is why that cancels out. I have to bring down my 6x, I cannot lose it. So I've got 6x equals. Now we have to figure out what is negative 6 plus 18. That will give us an answer of 12. Now that says 6 times x. I want to get x by itself. So I'm going to divide 6 from this side, and then also divide 6 from this side. 6 divided by 6 is 1. So that gives us the 1x that we are looking for. If I divide this side by 6, I also have to divide this side by 6. 12 divided by 6 is 2. So I now have my x equals positive 2. I now have to take this 2 and plug it in to solve for y. So I know that x equals negative 2. I can take it and I can plug it in to my second equation to solve for y. I have that y equals 4x minus 9. But now every time I see x, I'm going to plug in what x equals, which is positive 2. So my new equation is y equals 4 times 2 minus 9. When I multiply 4 times 2, I get 8. So y equals 8 minus 9, which brings us to y equals negative 1. When we write our final answer as a point, it's going to be x, comma, y. Our final answer will be 2, negative 1.